In this episode, we are going to focus on one of the most visible risk areas in any cloud environment, which is how your systems are exposed to the internet and who can reach them. When people first move workloads into the cloud, it often feels natural to make services publicly accessible because the internet is how users connect. However, not every component needs to be reachable from anywhere in the world. External access should be deliberate, minimal, and aligned with actual business requirements. The more public endpoints you expose, the more entry points attackers can scan, probe, and exploit. Controlling external access begins with understanding which services truly need to be public and which should remain private. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A public endpoint is simply a service interface that can be reached over the internet using a public address or domain name. That might include a web application, an application programming interface, or a management interface if misconfigured. When you hear public endpoint, think of it as a door that anyone on the internet can knock on, whether they are a legitimate customer or a malicious scanner. Attackers constantly scan large ranges of public addresses looking for exposed services, outdated software, or weak authentication. If your service does not need to be publicly reachable, leaving that door open is unnecessary risk. The safest endpoint is the one that is never exposed in the first place. The first principle in controlling external access is reducing your attack surface, which means minimizing the number of publicly reachable systems. If a database is only used by an application server, it does not need a public address. If an internal administrative dashboard is only used by staff, it should not be internet-facing. By keeping internal components on private networks and allowing only required entry points to be public, you create layers that an attacker must cross. Each removed public endpoint eliminates an opportunity for probing and exploitation. Reduction is often more powerful than adding new defensive tools. Private connectivity is the complementary strategy to limiting public endpoints. Private connectivity means that systems communicate over internal network paths rather than across the open internet. In cloud environments, this often involves virtual networks that isolate workloads from direct public exposure. When services talk to each other privately, their interfaces are not visible to the wider internet. This reduces the chance of unauthorized access and makes scanning far less effective. The goal is to design architectures where public exposure is the exception rather than the rule. Many beginners assume that strong authentication alone is enough to protect public endpoints, but exposure itself carries risk. Even with good authentication, public services can be targeted by denial of service attacks, vulnerability scanning, and brute force attempts. Limiting public exposure reduces the volume of hostile traffic your systems must handle. It also simplifies monitoring because internal traffic patterns are more predictable than internet traffic. Authentication is important, but it should not be the only barrier between a critical system and the entire internet. Network exposure decisions must support authentication controls, not replace them. Management interfaces are especially sensitive when it comes to external access. Administrative consoles, remote management ports, and configuration APIs are high-value targets because they provide powerful control over resources. Exposing these interfaces publicly, even with credentials required, dramatically increases risk. A safer design restricts management access to private networks or controlled entry points. For example, administrators might connect through a secure gateway rather than directly to each resource. This creates a narrow, monitored path instead of many scattered internet-facing management endpoints. Another important concept is segmentation, which divides your network into logical zones based on trust level and function. Public-facing services might live in one segment, application servers in another, and databases in a more restricted segment. Segmentation ensures that even if a public endpoint is compromised, the attacker cannot automatically access everything else. Private connectivity enforces these boundaries by allowing only specific, approved communication paths between segments. Instead of a flat network where everything can talk to everything else, segmentation creates controlled pathways. This design reduces lateral movement opportunities. Application programming interfaces often introduce accidental public exposure because developers need to integrate services quickly. An API might be exposed publicly for convenience during development and then forgotten when the system moves to production. Without regular review, these temporary exposures can become permanent attack surfaces. Controlling external access means auditing which endpoints are public and verifying that each one has a clear business justification. If no clear reason exists, the endpoint should be restricted or removed. Regular review prevents exposure drift over time. Conditional access controls can also support external access decisions by limiting how public endpoints are used. Even when a service must be public, you can restrict access based on identity, location, or device posture. This adds another layer of filtering beyond simple internet reachability. For example, a web application may be publicly accessible, but administrative features might only function for authenticated users meeting strict criteria. Conditional logic reduces risk without eliminating necessary exposure. It aligns accessibility with context. Another risk area involves misconfigured storage or data services that become publicly accessible without intent. Sometimes a storage bucket or file share is left open to the internet because of an incorrect setting. These exposures can leak sensitive information without any authentication barrier. Controlling external access, therefore, includes verifying default deny behavior, ensuring that resources are private unless explicitly made public. Secure defaults are powerful because they prevent accidental exposure from simple mistakes. When the default state is private, exposure must be deliberate. Monitoring plays a crucial role in external access control because visibility reveals both intentional and accidental exposure. Logs can show which endpoints are receiving internet traffic and whether that traffic aligns with expected patterns. Unexpected inbound connections may indicate misconfiguration or reconnaissance activity. Regular scanning from your own perspective can also help identify which services are publicly reachable. If you cannot clearly list your public endpoints, you cannot effectively protect them. Visibility supports accountability. It is also important to consider outbound connectivity as part of the external access story. Systems that can freely connect to the internet may communicate with malicious infrastructure if compromised. Restricting outbound traffic to approved destinations reduces this risk. Private connectivity and egress controls together limit how systems interact with external networks. Controlling both inbound and outbound paths creates a more balanced security posture. Exposure is not only about who can reach you, but also about where your systems can reach. When public exposure is unavoidable, protective layers such as web application firewalls and distributed denial of service mitigation can reduce risk. These controls filter traffic, block known malicious patterns, and absorb large volumes of hostile requests. However, they should supplement rather than justify broad exposure. The best practice remains minimizing public endpoints first, then protecting the ones that must remain. Protective layers are most effective when the attack surface is already small. Reduction and protection work best together. Documentation and governance complete the picture by ensuring that exposure decisions are reviewed and approved. Each public endpoint should have a clear business owner and defined purpose. Periodic reviews confirm that exposure remains necessary and that controls are functioning correctly. When endpoints are decommissioned, they should be removed from public reach immediately. Governance prevents exposure from expanding quietly over time. Control is an ongoing process rather than a one-time configuration. By understanding that every public endpoint is an invitation for global interaction, you begin to treat exposure as a strategic decision rather than a default state. Limiting public access reduces attack surface, simplifies monitoring, and decreases the chance of exploitation. Enforcing private connectivity for internal components ensures that most systems are shielded from internet-wide scanning. Segmentation, conditional access, monitoring, and protective layers reinforce this approach. Together, these controls transform external access from a broad, open boundary into a carefully managed interface. That disciplined mindset is essential for building secure and resilient cloud architectures.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.